In July 2024, a new car factory opened in Rayong, Thailand. That would normally be unremarkable. Thailand has spent more than half a century becoming one of Asia's great car-making centers. But this factory did not belong to Toyota, Honda, or Isuzu. It belonged to BYD. The Chinese company says it completed the plant in only 16 months. Stamping, welding, painting, final assembly, and component production sit inside one complex designed to build 150,000 vehicles a year. 1 year later, Chinese-made electric cars represented roughly 3/4 of Thailand's electric car market. And yet, Japanese manufacturers still supply around 2/3 of all cars sold across Southeast Asia. Both facts are true. One describes the car industry that dominates today. The other describes the industry being built for tomorrow. So how did China break into a market whose roads, factories, dealers, and suppliers were built around Japan? First, winning needs a definition. China has not taken over Southeast Asia's entire car market. Most vehicles sold in the region still burn petrol, and most still carry Japanese badges, but electric cars are the fastest changing layer of that market. In 2025, Southeast Asian electric car sales more than doubled to over 500,000. Electric cars approached 1 in every 5 new cars sold in the region. More than half came from Chinese brands, while roughly another third came from Vietnam's VinFast. Thailand reached almost 1 electric car in every 4 new sales. Indonesia reached 15%, the Philippines approached 10%, and Malaysia reached around 7%. One definition matters here. International statistics usually count battery electrics and plug-in hybrids together, but in Southeast Asia, more than 90% of electric car sales in 2025 were fully battery electric. So this is not mainly a story about adding a small battery to the old car. It is a story about replacing the old car's most valuable machinery and moving the center of the industry with it. For decades, Southeast Asia's car industry ran through Japan. Japanese automakers began establishing factories in Thailand in the 1960s. Assembly plants attracted parts makers attracted tool companies, logistics providers, industrial estates, and skilled workers. Japanese development finance helped connect those factories to roads and ports. This created a system that was extremely difficult to challenge. A Toyota was not simply a vehicle arriving at a showroom. It was the visible end of a regional machine. Engines, transmissions, stamped metal, finance, dealers, mechanics, spare parts, and decades of consumer trust. Chinese companies entered this contest from behind. They did not possess generations of engine expertise or mature global dealer networks. Competing directly with Japan's combustion cars meant playing a game Japan had spent decades perfecting. Then the architecture of the car changed. An electric vehicle does not need a fuel system, a multi-speed transmission, or hundreds of moving engine parts. Its strategic center is the battery, electric motor, power electronics, and software. That did not make car making easy. It made a different set of capabilities valuable. China had spent years building those capabilities in electronics, chemicals, batteries, and high-volume manufacturing. Then government policy created a market large enough to connect them. National support for what China calls new energy vehicles began in 2009. Pilot cities purchased electric buses and cars. Buyers received subsidies and tax advantages. Some large cities made license plates easier to obtain for electric vehicles. Governments funded charging networks, research, factories, and public procurement. Later, credit rules pushed manufacturers to sell cleaner vehicles. This support mattered. OECD evidence finds that Chinese car makers generally received more assistance relative to revenue than manufacturers based in OECD countries. But the subsidy explanation is incomplete. Government support produced waste as well as progress. Weak companies entered. Fraud appeared. Many electric car specialists never achieved sustainable profits. The National Purchase Subsidy Program was gradually reduced and ended in 2022, although tax relief and wider industrial support continued. The government did not simply choose one winner and hand it the market. It created an arena. Inside that arena, dozens of manufacturers fought over price, range, charging, software, styling, and survival. By the end of 2025, China offered nearly 700 electric car models, about 60% more than its number of conventional models. It was the only major car market with more electric electric models than combustion models. Policy created the demand. Competition turned that demand into an industrial pressure cooker. The most important result sits underneath the floor of the car. In a conventional vehicle, decades of advantage are stored inside the engine and transmission. In an electric vehicle, much of that value moves into the battery and powertrain. The battery alone represents roughly 1/4 of a typical battery electric car's value. The full powertrain represents about 1/3, and this is where China's scale becomes difficult to match. In 2025, China produced more than 80% of the world's battery cells, around 85% of cathode active material, and more than 90% of anode active material. Chinese producers supplied almost 3/4 of the batteries installed in electric cars worldwide. That concentration created a flywheel. More cars justified larger battery factories. Larger factories improved production yields. Better yields lowered battery costs. Cheaper batteries made cheaper cars possible, and cheaper cars created more demand. Chemistry helped too. Chinese manufacturers pushed lithium iron phosphate, or LFP, batteries into the mass market. LFP generally offers lower cost and avoids nickel and cobalt, although it stores less energy for the same weight than some alternatives. In 2025, LFP supplied more than half of global EV battery demand. Average LFP packs were more than 40% cheaper per kilowatt hour than nickel-based alternatives, although part of that gap reflects different applications and performance requirements. Across all chemistries, average battery pack prices in China were 30% below North America and 35% below Europe. China's advantage is therefore not one miraculous battery. It is the industrial neighborhood surrounding the battery: material processors, cell makers, equipment suppliers, electronics firms, vehicle plants, and millions of customers testing the result. This changes what cheap really means. The International Energy Agency estimates that producing a small SUV in China costs more than 30% less than in advanced economies for both electric and combustion versions. Scale and vertical integration explain most of the advantage. Lower wages and energy prices matter, but less than many people assume. For electric cars specifically, lower powertrain costs explain almost 40% of the manufacturing gap. In battery cells, about half of the gap with Europe comes from manufacturing efficiency and automation. Another 30% comes from access to lower cost components and critical mineral supply. Then there is software. Electric vehicles increasingly use central computers to control functions that older cars spread across dozens of separate modules. That architecture allows manufacturers to update features remotely and change the vehicle without redesigning every mechanical system. The result is a shorter feedback loop. A company launches a car, drivers reveal what works, software changes, components are redesigned, prices move, a new model follows. By 2025, nearly 70% of battery electric cars sold in China were already cheaper than comparable combustion cars before incentives. Those prices are partly the product of brutal competition and very thin margins. But when Chinese companies arrive in Southeast Asia, they arrive after surviving a market far larger and faster than the markets they are entering. China's domestic machine explains supply. Southeast Asian policy explains access. In 2025, China produced about 16 million electric cars, nearly 3/4 of the global total. Output exceeded domestic demand by roughly 20%, and Chinese electric car exports doubled to more than 2.5 million. Sales in Southeast Asia grew around 130%. Some manufacturers even commissioned their own roll-on roll-off ships to move cars abroad. Governments across the region wanted cleaner transport, less exposure to imported fuel, and a share of the next automotive industry. But they did not only subsidize buyers, they used temporary import advantages to pull factories into their countries. Thailand's EV 3.5 program shows the bargain clearly. Participating manufacturers could receive lower import duties and excise taxes. In return, imported vehicles had to be offset by local production. 2 Thai-built cars for each qualifying import in 2026 and 3 in 2027. Chinese manufacturers accepted the deal. In Thailand, electric car sales rose 70% in 2025 to roughly 140,000. Locally made electric cars increased from about 5% of the market to 20% in 1 year. BYD, SAIC, Great Wall, and other Chinese groups had moved from shipping cars to operating or supplying assembly lines. Indonesia followed a related path. Electric cars reached 15% of new sales in 2025. About 3/4 were imported from China, while Chinese-owned Wuling supplied much of the local production. The next stage is designed around Indonesian assembly and around the country's attempt to connect its nickel resources to batteries and vehicles. Malaysia's electric share was smaller at about 7%, but Chinese imports supplied as much as 80% of the segment. Even the national champion tells a more complicated story. Proton's electric models draw heavily on its partnership with China's Geely. In the Philippines, electric car share jumped to almost 10%. Chinese imports, especially BYD, supplied most of the market, supported by zero duties on specified electric and hybrid vehicles through 2028. Singapore is smaller but revealing. Battery electric cars reached 45% of new registrations in 2025, and BYD registered more than 11,000 cars, enough to become the country's best-selling new car brand overall, ahead of Toyota. By 2025, Southeast Asia contained more than half of Chinese car makers' entire overseas manufacturing footprint. Thailand represented more than 30%, and Indonesia more than 20%. This is the real export strategy. First, ship the car, then ship it in pieces for local assembly. Then bring the factory, selected suppliers, battery relationships, software platform, and finance behind it. China is not merely exporting vehicles, it is exporting a production system. This can make Japan's manufacturers look as if they simply missed the future. The reality is less comfortable and more rational. Japanese companies built enormous advantages in reliable engines, hybrids, pickups, supplier quality, service networks, and resale value. Their customers often live in markets where charging remains inconvenient, and a dependable hybrid solves an immediate problem. In Japan itself, ordinary hybrids represented roughly 1/3 of new car sales in 2025. Electric cars remained below 3%. So Toyota's strength in hybrids is not evidence that it forgot how to understand customers. It reflects a transition moving at different speeds, but the growing Southeast Asian EV segment rewards capabilities that are not identical to those strengths. Low-cost batteries, centralized software, frequent model launches, digital interiors, and rapid price changes. The old network is large. Incumbent manufacturers led by Toyota and Hyundai hold about 1.2 million vehicles of dual combustion and EV capacity in Southeast Asia. Yet in 2025, the relevant plants produced fewer than 2,500 electric cars. That is the incumbent's dilemma. The factories, suppliers, and processes that make a company efficient at the old product can make it cautious about replacing that product. Japan has not lost Southeast Asia, but China has moved first into the part of the market growing fastest. And that lead is not universal. Vietnam became Southeast Asia's largest electric car market in 2025. Almost 40% of new cars were electric, but the market was supplied overwhelmingly by VinFast, a Vietnamese manufacturer. India followed a different model. Electric cars reached only around 4% of sales, and roughly 60% were produced domestically by Tata and Mahindra. High import duties and local production rules make an import surge much harder. Korea has powerful domestic manufacturers. Japan has its own brands, policy choices, and consumer preferences. These exceptions reveal something important. Chinese dominance is not the automatic result of superior technology. It is strongest where Chinese industrial capability meets an open market, supportive incentives, and local manufacturers that have not already occupied the affordable EV category. Policy does not merely accelerate this market. Policy helps decide who enters it. Even in Southeast Asia, factory announcements can hide a more fragile reality. In 2025, Chinese-owned battery electric production capacity in Thailand operated at only around 20% on average. In Indonesia, utilization was below 15%. China also exported far more electric cars than overseas customers actually bought. Reported exports exceeded overseas sales by more than 25%, suggesting inventories were building up in destination markets. That matters because a shipment is not a customer and a factory is not not an industry. Low utilization destroys profit. Constant price cuts damage resale values. A manufacturer that disappears can leave buyers with weak service, scarce parts, and uncertain warranties. Charging is improving, but unevenly. Thailand had nearly 12,000 public chargers in 2025, yet EV adoption grew faster than the network. The number of cars per public charger rose from 19 to 30. Indonesia had deployed more than 4,500. And local assembly does not guarantee local control. A vehicle can be welded and painted in Thailand, while its cells, battery materials, power electronics, software, and key equipment remain Chinese. Southeast Asia may gain jobs and exports, while the most valuable bottlenecks stay somewhere else. The region could replace dependence on Japanese engines with dependence on Chinese batteries and digital platforms. That would still change who wins. It would not necessarily mean Southeast Asia wins with them. Return to Rayong. Decades ago, Thailand learned to build cars through Japanese investment. Today, it is learning to build electric cars through a new wave of Chinese factories. The badge on the hood is only the visible layer. Underneath it sits the real contest. Who makes the cells, who controls the software, whose suppliers improve with every model, and who keeps the profit when the car is sold. China is winning the opening phase because it built the market, the supply chain, and the competition at the same time. But the final outcome is not settled. Japanese manufacturers still own scale, trust, dealers, and much of the total market. Chinese manufacturers must turn low prices and new factories into reliable service and sustainable profits. And Southeast Asian governments must turn assembly into skills, suppliers, and technology they can eventually control. The first EV race was about selling cars into Southeast Asia. The next one is about who owns the industry underneath them.